Some people worry that future quantum computers could one day break the encryption protecting everything online. Not just your crypto, but the entire internet. It's a scary thought. But how real is the threat? Could it actually kill crypto, or is this just another overhyped apocalypse story? The truth is, there's something to it. Quantum computing is real, and it will change how we secure the digital world. But change doesn't mean the end.
Remember Y2K back in the late 1990s?
People genuinely thought planes would fall from the sky, and ATMs would stop working when the clocks hit the year 2000. Computers back then only stored the last 2 digits of the year. So when the clock rolled over to 00, many systems would think it was 1900, not 2000. That could have crashed everything from flight software to banking systems. And then nothing happened. But because the threat was fake, but because engineers saw it coming and fixed it in time, that's exactly what's happening with quantum computing. We know the risk, and we're fixing it before the hardware even exists to cause the problem. So what exactly is the problem? To understand that, we need to talk about what quantum computing actually is. And that's no easy task. The physicist Richard Feynman once joked, "If you think you understand quantum mechanics, you don't understand quantum mechanics." Here's the simple version. Your computer runs on bits. They can be either a 1 or a 0, like a light switch that's on or off. Quantum computers use qubits, and qubits don't have to pick between 1 or 0. They can be both at once. That's called superposition. Then there's entanglement, which happens when 2 qubits are linked so that changing one instantly affects the other, even if they're miles apart. Put those 2 things together and you get a machine that can explore many possible answers at the same time. That makes it exponentially faster for certain kinds of problems, including the kind of math that keeps crypto and online security safe today. In short, computers are about to get far more powerful. Powerful enough that one day they could solve problems that would take today's machines centuries in just a few minutes. That's incredible for science, medicine, and research, but it's also why it makes some people nervous. Because everything online, from your bank password to your crypto, depends on mathematical problems that are hard for normal computers to solve. And quantum computers could solve those problems much faster. And that's where 2 famous quantum algorithms come in: Shor's algorithm and Grover's algorithm. Shor's is the big one. It's a mathematical shortcut that could one day take a public key, like the one used in Bitcoin, and figure out the private key behind it. That could allow someone to move coins they don't even own. But don't panic just yet. Running Shor's algorithm successfully requires a specific kind of quantum computer that can perform billions of precise operations without losing accuracy. See, as incredible as quantum computers are, they're extremely fragile. Qubits are sensitive to the smallest changes in temperature, vibration, or electromagnetic noise. They decohere, which means they lose their quantum state and the information disappears. To prevent that, engineers have to use error correction, combining many imperfect or physical qubits to form one reliable, logical qubit that can hold and process information correctly. To run an attack like Shor's on Bitcoin's encryption, you'd need a few thousand logical qubits. But to get those, you'd first need millions of physical qubits to compensate for all the instability. And we're not there yet. IBM and Google have built machines with a few hundred qubits at best. That's incredible progress, but still nowhere near close to what's needed to crack encryption. Then there's Grover's algorithm, which speeds up brute force attacks, where an attacker tries every possible answer until one fits. In Bitcoin's case, it can reduce the effective strength of its SHA-256 hashing from 256 bits to about 128 bits. That sounds dramatic, but 128-bit security is still considered extremely strong. It's the same level used in modern online banking and secure messaging. And if the day ever came when that felt too low, the fix would be simple: upgrade to a longer hash. So yes, quantum computers could one day threaten crypto, but not today and not anytime soon. The machines that exist right now are exciting for research, not for breaking Bitcoin. What they really do is remind us how important it is to build security that's ready for the future. So how are we preparing for the quantum future? Most experts think we're at least 10 to 15 years away from having a quantum computer capable of breaking Bitcoin. By then, we'll already be using quantum-safe encryption. Governments, researchers, and tech companies have been preparing for this for years. In 2024, the US National Institute Institute of Standards and Technology finalized the first post-quantum cryptography standards. They include new algorithms like Kyber for secure key exchange, and Dilithium and Sphinx Plus for digital signatures. These are already being rolled out across browsers, cloud services, and communication systems, which means the internet itself is becoming quantum safe by default. Bitcoin and other blockchains can follow the same path. Developers are already discussing upgrades that would let users move their funds into new quantum-resistant wallets well before any real threat appears. And remember, if a quantum computer ever became powerful enough to break Bitcoin, it wouldn't just break crypto, it would break everything. Banks, governments, communication networks, the entire internet. That's why this isn't just a crypto issue. It's a global security challenge, and the entire digital world is working on it together. The quantum threat is real, but it's distant, and most importantly, it's solvable.
Just like Y2K, we saw the problem early.
And we're fixing it before it happens. In fact, quantum computing will probably be a net positive for humanity. It will help us discover new medicines, design better materials, and solve complex problems we can't even imagine yet. And it's already forcing us to build stronger digital security for the future. So no. Despite what the headlines might say, quantum computing isn't the end of crypto. It's the next evolution of digital security and proof that crypto never stops adapting. So what do you think? Is quantum computing crypto's biggest threat? Or are the fears a little overhyped? Either way, it's a good reminder of how important security really is. Share your thoughts in the comments, make sure to subscribe, and let us know what you'd like to see next.